Thank you for joining me today. I hope you can hear me well. This is Jose Fuentes, and the topic of today's webinar is controlling the values of signals in your requirement specifications, or how to connect your requirements documents with your project dictionary. These are going to be the topics to cover today after a brief introduction of the reuse company and myself. We will introduce briefly the concept of signal. What is a signal? An example of these signals and messages within the automotive domain. And then we will conclude with representing or viewing how all these can be represented in our tool KM, Knowledge Manager, and how signals are involved in textual requirements. Last block will be a live demo, and finally a Q&A section. So quickly, very quickly, speaking, the reuse company was established in 1999 as a spin-off of a local university here in Madrid. Is aiming at developing software for systems engineers. The headquarters is still in Madrid, with one international office in Stockholm, another one that we have just opened in Miami, the USA, and a very special delegation in Tokyo, in Japan. These are now the tools that conform our portfolio. In this new version, V22, we have included the SES Engineering Studio, and part of my demo will be on top of this tool. And this is myself, Chief Sales Manager at the reuse company. I am a CSEP certified, graduated from the Institute for Technical Leadership of INCOSE, a member of the Spanish chapter of INCOSE AES, active contributor to the INCOSE Guide to Writing Requirements, and I'm also certified ITIL. So signals and messages. First, what is a signal? If we go and refer to a common purpose dictionary, then we find, as you can imagine, a large definition of what a signal is. I would like to highlight a couple of those inputs. First, like something that incites an action. In the field of requirements, I do think that these resemble a little bit the notion of a condition in a requirement, and an object used to transmit or convey information. For me, it has to do with interfacing between components or between systems, right? In the field of systems engineering and SysML, in this slide, we defined a signal like a specification of a type of sending request instances communicated between objects, right? So to me, again, it has to do a lot, this definition, with the notion of interfaces between different components, missing a little bit the notion of condition, as, by the way, can happen in a state chart for a state transition triggered by a signal in some of the cases, right? So an example of those signals now in the automotive domain, I would like to highlight. I'm not an expert on this topic, by the way, so I hope I don't make mistakes in what I'm going to say, but I understand that this CAN bus is one of the key aspects of modern car nowadays, and this is a bus that enables the exchange of messages between different components, right? So the idea is that within this CAN bus, you can find these frames or frames with this structure. And the good point, or what is connected to the notion of a project dictionary that I'm introducing today, is the idea of those database CAN files, right? DBC. In those files, you can find the definition of the different messages, and within the messages, different signals. Messages in blue, the first line in this picture that I took as a reference from this csselectronics.com website, and messages, and signals in yellow, orange below, where for each one of the messages you can find the name of the message itself, and you can find also the sender. For each of the signals, you can find a lot of information, including the name of the signal, the the minimum value, the maximum value, the units, the receiver of the eventual or possible receivers of this signal. So this conform a full file of a full database with all the definitions of all those signals. And what is pretty much connected to what you are going to see today is the notion of controlling in your requirement specifications the senders of your signals, the receivers of your signals, the possible values, the possible units within the signals, and so on and so forth. So this is the idea, and this is the way we have connected all this information into our tool knowledge manager, right? So that messages and signals are represented as clusters within, for those of you who already know a little bit about our approach. So messages and signals, we have created a cluster called message and a cluster called signal, where all the signals and messages belong to. Then the different properties of the signals, like the maximum value, the minimum value, are represented as properties for the concept of the signal within the KM. You are going to see this in a minute. While the other property, like the possible units, are represented as relationships in KM. Same for the notion of senders and receivers with different relationships in our ontology, linking the components and signals with two different semantics, one for the senders and one for the receivers. And that's all. So with all this, and these are two screenshots of our tool KM Knowledge Manager, where you can see in the left different number of components, like component 1, 2, 3, engine, gearbox, range sensor, and the eventual signals that can be sent. We are in the cluster, in the semantics of sending. So these are the signals that can be sent by the component on the top, right? In the second screenshot in here below, you can find that some of those signals are or can contain, of course, information like possible values, as not as a range of numbers, but as an enumerator, right? So in this case, what you can see is are those kind of signals, like enumerators with the potential possible values. For reverse gear, we have engaged and not engaged. For wiper speed, we have high, low, and medium speed, right? So this information can be imported in KM in a very easy way. I will show you now an Excel sheet that can be used to import this information. And before we go into the demo, the idea is that those signals can be involved in your requirements in plenty of different ways. Here you can find two different requirements. When the rain sensor detects drops of rain, the rain sensor shall set rain detected to 0.01 and set wiper speed to lower speed, for instance. In here, you can notice that this is the action. I have highlighted in green here the action to distinguish from the condition. And in here you can find already a couple of different signals, like rain detected or wiper speed, that could be identified as signals in the action. In the second requirement, I have included a couple of different signals, but in this case, it is not in the action, it is in the condition. So the reverse gear is a signal, and rain detected as coming from the previous requirement is also a signal, right? So the point here is, or what is going to be the topic of today's webinar is how can we control the way we use these signals? Like, can the rain sensor send the signal rain detected? Or I mean, if you go back, for instance, to the example of the DVC file, is there any constraint telling me that this signal can be sent from this component? Yes, no. Or is 0.1 within the range of possible values for this signal? Or is also low speed possible value in an enumerator for the wiper speed signal. So all these are questions that we are going to solve in the demo. Or is kilometers per hour the right unit for the speed of the engine, or should we measure the speed of the engine in revolutions per minute instead of kilometers per hour, right? So let's go into the demo. I have prepared a video for you. Where I will demonstrate all this. So this is the SES Engineering Studio, the new tool that we have released this year. I have connected to a database where we have established, or we have collected different signals and constraints for the signals. I have used this Excel sheet with all the signals that I'm going to use in this demo, all the name of the components, all the possible values, and so on and so forth. This first sheet in the workbook is just representing the different elements for the ontology, while in this other RSHP, what I'm doing is I'm connecting by means of different semantics. I am connecting different elements like possible signals with the possible values, or with the notion of sender or receiver. We are connecting as well components with signals with these two different semantics of sender and receiver, right? So all this, as mentioned, can be very easily be imported into KM, and the result could be something like this, something like a number of different clusters and a number of different signals within each one of those clusters, like enumeration signals or numeric signals that require unit, or dimensionless signals, those that are not requiring a unit together with the value. So all this is now part of the ontology. In here, I can show you, for instance, the possible values as a range of numbers from 0 to 1,000 in this case. All these can be defined or modified in KM in a very easy way, right in the way you normally deal with the other ontologies in KM, right? So once we have seen all this information, now we can move to the requirements, right? And in here, connecting to the ontology where all those signal information or signal names and the properties appear. And I will do my demo with just three very simple requirements, but I guess that enough as to demonstrate what we can do with those signals, right? So these are my three requirements, and before we analyze the quality of those requirements, I will show you briefly the 6 rules that we have implemented in this very simple library. Metrics to detect whether or not the measurement unit that appears with a signal is correct or not. This is very similar to the way we do with properties. We check the sender, we check the value if it is in a list. We check if the units are missing for those signals requiring a unit, or we also check if the name of the signal is invalid or unknown, or if the value is unknown, right? So these are the rules that I want to check for my requirements. So I go back to the definition of my requirements and analyze, of course, 3 requirements. It takes almost nothing to analyze the quality of my 3 requirements. And the result is that these 3 requirements are having an issue, at least one issue, each one of them, right? So I maximize my screen. And then we start with the first requirement. So you can see for the free, you can see quickly the issue by hovering your mouse over the star. But if you double click on it, then you have the requirements authoring tool telling you, in this case, that there is an invalid measurement unit, right? So it seems that kilometers per hour is not the proper measurement unit for the speed of the engine, right? So in this case, I'm going to replace this. By the way, if I remove the kilometers per hour, then I have another issue like missing units, because the tool is expecting that after the number, it has to come the unit, right? It is important to mention that in this very same requirement, there is another number here, but this number is connected to a signal which is within the cluster of dimensionless signals, right? So this is why the tool is not forcing you to have unit after this number. However, the engine speed is a signal that requires unit. So that's why if I remove the kilometers per hour, then I had the issue of missing units. Now, if I replace by revolutions per minute, then I have a green quality. So wow, the first is fixed. Let's move into the second. There are a couple of issues into this second requirement. The first one is invalid value. The second one is unknown signal. So invalid value, why? Because reverse gear, the value OK is not within the potential values of reverse gear. Of course, now I know by heart that engage is a possible good value for reverse gear. Other ways to know that is, for instance, just by hovering the mouse over the name of the signal. It is not in the video, sorry, but then if you move the mouse over the reverse gear signal, then you will see the definition with the potential values. And I will show you yet another more sophisticated way to know the possible values in the next requirement. So the second issue is the unknown signal. So fake signal is a signal which is not in the list of possible signals in my dictionary. So that's why the tool is complaining and telling me that fake signal is not a good signal. So I will replace this action by a different action. Like in this case, I'm not going to involve any signal, just the car shall light the reverse lights. And if I click now and pick a pattern, then I can see that this other frame on the left, the green frame on the left, is telling me that my requirement is fitting with the structure of a functional requirement, which is the one that I have selected there, right? But I will show you in more detail this writing assistant, right? So if I now open the third requirement, this is pretty much a copy of the previous one. So what we can do is we can create a new requirement, or we can edit this requirement just to modify it completely, by the way. So I empty the requirement, I pick my pattern, and now I will choose a functional requirement where the condition includes a signal, but the action is also to send another signal. So I start typing, and as you can see, and as is normal with our authoring tool, then you see all the name of the components and all the names of the signals that appear from the dictionary. So when the rain sensor detects drops of rain, for instance, of rain, comma, and now the action, the rain sensor shall send. I choose my verb. The action is just for sending signals, so I have only two options, send and set. So I continue. Shall set. And now it is important because in my dictionary, if you remember from KM, I had a large number of different signals. However, in here, the tool is only suggesting me the name of 3 possible signals. Why? Because, and by the way, this is something new in this version 22. And now the patterns can include contextual restrictions. So meaning that these are the only 3 signals that have a relationship of type send between the component rain sensor and the signal. So there are only 3 signals that can be sent from the rain sensor. So that's why I can only choose among one of these 3 signals. So I choose my signal. In this case, I'm going to choose a wiper speed because it is a signal that requires a value from an enumerator, right? So I choose or I can start with rain detected. This is a number. So shall set rain detected equal 0.3. You can notice that the green frame on the left is telling me that the requirement is fitting with the structure, so it is a well-formed requirement. However, if I check consistency in here, then I will see that there is an issue. The value expected is between 0 or 1. The value 3 is out of the range. So now I have to, if I modify and I write as a 1, as a value of 1, now there is no issue found, right? So this is the way we control in real time the value for numerical signals. If I go now and replace this by an enumerator signal, like wiper speed, then what I see here are 3 possible values. Similarly to what happened with the name of the signals, in my database there are plenty of other possible values like engage or not engage and so on and so forth, right? But these are the only 3 values connected to the signal wiper speed. So the tool is sorting out the number of options in those drop-down lists only to those that are fitting with the semantics of the information from the ontology or from the project dictionary, right? So that's why if I now go and choose one of these 3 possible values, I hope that everything will be in green exactly. So the structure is okay, and there are no issues detected, so everything is in green. And okay, that's all for today. Remember that it was a short webinar. Now it is time for you. If you have any question, please go ahead with your questions.
Yes, we have a question here. Hello, Jose. How do you check that the unit matches with the action? I mean, revolutions per minute with the rotation velocity.
Well, in this case, we are forcing somehow the check or the match between the signal itself and the unit. If you think, or yes, it is another way of fixing this problem. If you think that the match should be between the action and the unit, then you can do exactly the same. You can link in the ontology the action and the unit and force always to meet with one of those actions that you have enabled in the ontology.
Thank you. No more questions.
Okay, so my last word is just a reminder for our next webinar. We are approaching Christmas time, so our next webinar will be in January, where we, in collaboration with SimData, will be presenting a webinar called Systems Engineering Rigor Needs and Interoperability Framework, where we will describe in detail the notion of digital thread and the notion of interoperability within the context of our new tool, SES Engineering Studio. We will co-host this with SimData, as I said, and one of the presenters from SimData, Craig Brown, will be providing you insights and details on this new approach. So that's all for today. Thank you very much. I hope we stay in touch in this series of webinars next year. Thank you very much. Bye for now.